Welcome to the Explainer. Today, we're going under the hood of the AI that's, well, pretty much changing everything to figure out what's really going on inside the machine.
So you've definitely done this. You ask ChatGPT or some other AI to write an email, maybe even an essay, and poof, like magic, a response just appears. But here's the thing, it's not magic. It's a fascinating, incredibly complex, and, yeah, a deeply flawed process. So what is actually going on in there?
All right, so here's our game plan for this explainer. We're going to start with the absolute basics. What even is a language model? Then we'll get into the massive billion-dollar problems they're facing. After that, we'll walk through the training pipeline that developers use to fix those problems, explore the tricky business of teaching AI human values, and finally, we'll look at why this whole thing is still very much a revolution in progress.
So let's dive right in. What exactly is a large language model? How does it go from spitting out what is basically random nonsense to writing a coherent, grammatically correct sentence?
Okay, so at its heart, a large language model, an LLM, is really just a giant pattern matching machine. Think about it. It's been trained on a massive chunk of the internet, books, articles, websites, you name it. But here is the most important part. It doesn't understand any of this the way you and I do. It just learns the statistical relationships between words on a mind-boggling scale. So how does that work in practice? Well, it's actually simpler than you might think. When you give it a prompt, say, a flash flood watch will be in effect all, the model does one thing and one thing only. It predicts the next most likely word. It's seen the phrase all night thousands, maybe millions of times in its training data, so it predicts night. Then it just adds that word to the sentence and does the whole thing over again, predicting the next word and the next and the next, building its response token by token until the thought is complete.
But that simple prediction game hides some enormous complexity and some very deep flaws. For all the amazing things they can do, today's LLMs are built on a foundation that has some really serious cracks.
First of all, let's talk about the price tag. Training a state-of-the-art model is unbelievably expensive. We're talking an estimated $8 million just in computing costs for Google's Palm model. Yeah, $8 million. This is not a project you can do in your garage. This is an arms race fought between a handful of tech giants that own these massive data centers. And even after spending all that money, they still make stuff up. This is what researchers call hallucination, when a model just confidently says something that is completely, totally wrong. And it's not some rare glitch either. OpenAI found that even GPT-3 gets it wrong about 15% of the time. That's a huge deal when we're starting to rely on these things for actual facts.
And the list of problems just keeps going. I mean, look at this. These models can pick up and even amplify the worst biases from their training data. Their knowledge is frozen in time, so they know nothing about recent events. They have no real memory of past conversations with you. And on top of all that, there are major privacy risks and a real struggle with any kind of multi-step logic. This is the set of billion-dollar problems that the entire industry is racing to solve. So how in the world do you even begin to fix all of that? Well, the answer lies in this really careful multi-stage process called the training pipeline. This is where raw, messy data gets transformed into a capable and, you hope, a much safer AI. The whole journey really boils down to three big stages. First, you have to gather and just meticulously clean a gigantic data set. Second, you do what's called pre-training, where the model learns the basic patterns of language. And third, you fine-tune and align it so that it actually follows instructions and, it doesn't say terrible things. Let's break those down.
You've heard the saying, garbage in, garbage out, right? Well, that is the first law of AI. Before a model can learn anything, its diet has to be pristine. So this curation phase is this huge janitorial effort. You're filtering out ads and junk, scrubbing personal info like names and emails, and even using other AIs to rate text quality and just throw out the gibberish. Every single step is about creating a clean, high-quality data set so the model learns the right lessons.
And how this cleanup gets done really depends on who's building the model. On one side, you have the open source projects. They tend to prioritize transparency, publishing their methods and their data sources to build trust with the community. On the other side, you've got the big enterprise pipelines, which are often a total trade secret. They're all about performance and legal safety, using proprietary data as their competitive edge. It's that classic trade-off between openness and the secret sauce.
Okay, so once the model has learned language from all that curated data, we get to what is probably the hardest part of the entire process, making sure it behaves in a way that's actually helpful and safe for humans. This is the massive challenge of alignment.
There's this brilliant analogy that floats around in the AI research world. It describes a raw, pre-trained model as a kind of incomprehensible alien intelligence, a shoggoth that just has a smiling emoji mask slapped on its face. It looks helpful and friendly on the outside, but its underlying thought process is completely non-human and totally unpredictable. The whole goal of alignment is to make sure the model's actual behavior matches that smiling, helpful face we want to see.
So that's what we mean by alignment. It's the process of steering a model's behavior to make sure it's helpful, honest, and harmless. This isn't about making the AI smarter. It's about making it safer. It's the absolute critical step that turns a powerful but dangerous tool into something we can trust enough to release to the public.
The most popular way to do this is a technique called reinforcement learning from human feedback, or RLHF. It's a pretty clever process. First, you get a bunch of humans to simply rank different model responses to the same prompt from best to worst. Then, all that preference data is used to train a separate AI, a reward model that basically acts as an AI judge. Finally, you take the original LLM and you fine-tune it to generate answers that the AI judge will give a high score to. You're basically teaching the model what a good answer looks like from a human perspective.
And, all these little choices made during the pipeline, they have a huge, measurable impact. I know this looks complex, but the main takeaway here is pretty simple. Each of those colored bars is a different model. Just notice how some models are better at some tasks than others. That's not random. That's a direct result of the specific data they were trained on, how it was filtered, and how they were aligned. Every single decision matters.
So, where does all of this leave us? Well, it leads to our final and maybe most important point. As complex and powerful as this whole process is, we have to remember that this entire field is incredibly, incredibly young. This is very much an unfinished revolution.
I mean, just look at this timeline for a second. The core technology that powers all of this, the transformer architecture, was only invented in 2017. ChatGPT didn't even exist until late 2022. And now, just a short time later, the cutting edge is already moving on to models that can do complex, multi-step reasoning. The pace of change is just staggering.
So here's the bottom line. The models we have today are amazing feats of engineering, no doubt about it. But they are still just the beginning. They are powerful, but deeply imperfect tools. The next great challenge isn't just about making them bigger or faster. It's about making them truly safe, truly reliable, and maybe, just maybe one day, even wise.
Which leaves us with one final big question to think about. We've successfully taught these machines to speak our language with stunning fluency. But the real question is, can we ever teach them our wisdom? Thanks for joining us on The Explainer.